G'day, science lovers. Have you ever gazed up at the night sky, a vast blanket of stars stretching out into infinity, and wondered if there's more out there? Not just more planets or more galaxies, but more universes entirely. This is not just a question for science fiction films or late-night philosophical chats. It's a concept that some of the most brilliant minds in physics are seriously considering. The idea is called the multiverse. This is where physicist Max Tegmark comes in. He provided a brilliant way to organize all these different multiverse concepts into a clear, hierarchical system. He proposed a classification scheme with 4 distinct levels. Each level is progressively larger and stranger than the one before it. Think of it as a set of Russian nesting dolls. Each doll you open reveals another, slightly different one inside. Level 1, the simplest, suggests that space is infinite, and if you travel far enough, you'll eventually find regions just like ours with copies of you and me. Let's begin our journey with Tegmark's first level, the Level 1 Multiverse. This is perhaps the least controversial and most straightforward of all the multiverse ideas. Evidence from our best cosmological observations, like the shape of the universe being geometrically flat, strongly suggests that it doesn't curve back on itself. Think of it like having an infinite deck of cards. If you keep shuffling and dealing hands, you will eventually get the exact same hand of cards again. Not just once, but infinitely many times. In the same way, in an infinite universe, there must be other regions of space where the initial conditions were so similar to ours that they evolved in an almost identical fashion. Now you might be wondering, if these other universes are out there in our own space, why can't we see them? The answer lies in a fundamental speed limit of the cosmos, the speed of light. We can only observe light that has had enough time to travel from its source to our telescopes here on Earth since the Big Bang. It's a bit like being on a ship in the middle of a vast ocean. You can only see as far as the horizon, but you know the ocean doesn't just stop there. The regions beyond our cosmic horizon are the other universes in the Level 1 multiverse. They are real physical places just forever out of our reach. Somewhere out there, at an unimaginably vast distance, there's another galaxy that looks just like our Milky Way. Inside it, there's a star identical to our Sun, orbited by a planet identical to our Earth. On that duplicate Earth, a person identical to you is sitting and watching a video identical to this one. This person shares your memories, your thoughts, and your feelings. They are your cosmic twin, or doppelganger. Max Tegmark has calculated how far you would likely have to travel to find your nearest identical twin. The number is staggeringly large, a 1 followed by more than 100 zeros in meters. Every path not taken in your life has been taken by another version of you in distant universes. A universe where you took that different job or moved to that different city or said yes instead of no. Alright, let's now venture into the next level of the cosmic rabbit hole, Tegmark's Level 2 Multiverse. This is where things start to get a little stranger. The driving force behind this concept is a powerful theory in cosmology known as eternal inflation. It takes the idea of cosmic inflation and pushes it to its logical and rather spectacular conclusion. Imagine the inflaton field as a vast pot of boiling water. Our universe is like a small bubble of steam that formed and cooled down inside that pot, allowing structures like galaxies, stars, and us to condense. But outside our bubble, the rest of the water is still boiling furiously. This boiling of space-time is constantly spawning new bubbles, new universes, each one expanding and cooling down to become its own self-contained cosmos. Let's dive a bit deeper into what these bubble universes are actually like. In the eternal inflation model, each time a new bubble universe forms, it's a bit of a cosmic lottery. When a patch of the inflaton field decays from its high-energy boiling state to a lower energy state, a bubble is born. This is the Big Bang for that particular universe. The key difference between these bubbles and the different regions in a Level 1 multiverse is their complete isolation. The bubble universes are separated by space that is inflating faster than the speed of light. Our entire existence is playing out inside one sphere, while an infinite number of other cosmic dramas unfold in other bubbles, each one completely unaware of the others. Now we get to the most fascinating aspect of the Level 2 multiverse. These other bubble universes might not just be copies of ours. They could be fundamentally different. Think of water freezing into snowflakes. Every snowflake is unique because the exact conditions are slightly different for each one as it forms. In a similar way, the fundamental constants and parameters of physics might take on different values in each new bubble universe. But in another bubble universe, gravity might be 1,000,000 times stronger. In such a universe, stars would burn out in an instant, and anything larger than a pea would be crushed into a black hole. Alternatively, imagine a universe where the electromagnetic force was much weaker. In this bubble, atoms might not be able to hold together. The universe would be a diffuse, uninteresting soup of particles. This brings us to a deep and puzzling question in physics. Why are the fundamental constants of our universe so perfectly suited for life? This is often called the fine-tuning problem. For example, if the strong nuclear force were just 2% stronger, all hydrogen would have been fused into heavier elements in the Big Bang, leaving no fuel for long-lived stars like our Sun. The Level 2 multiverse offers a compelling answer to this puzzle. It uses the anthropic principle. In the context of the Level 2 multiverse, our universe is a Goldilocks bubble. We, as conscious observers, naturally find ourselves living in one of the rare bubbles where the conditions are just right for the evolution of intelligent life. Prepare yourselves, because we are now about to take a leap from the grand scales of cosmology into the infinitesimally small, yet infinitely strange realm of quantum mechanics. This brings us to Tegmark's Level 3 multiverse. Unlike the previous two levels, which involved traveling vast distances through space to find other worlds, this level suggests that other universes are being created constantly, all around us and even within us. At its core, quantum mechanics describes the behavior of matter and energy at the atomic and subatomic levels. Particles like electrons don't have a definite position or speed until you measure them. Instead, they exist in a fuzzy cloud of possibilities, a state known as a superposition. This problem is famously illustrated by the thought experiment of Schrödinger's cat. According to quantum mechanics, until we open the box and look, the cat is in a superposition of being both alive and dead at the same time. The Level 3 multiverse is born from an alternative explanation known as the many worlds interpretation, first proposed by physicist Hugh Everett III in the 1950s. Everett took a bold and simple approach. He suggested that the wave function never collapses at all. Instead, every single possible outcome described by the wave function actually happens. The many worlds interpretation completely reframes our understanding of reality. In this view, the universe is constantly branching, creating a vast and ever-growing tree of parallel timelines. This splitting isn't a physical, violent tearing of space-time. Think of it as the wave function of the entire universe, evolving into two separate, non-interacting states. The Level 3 multiverse provides a reality where nothing is ever truly lost to chance. Every possibility inherent in the quantum wave function gets to play out in its own universe. This means that things we consider to be impossible in our everyday lives are actually happening in some other branch of reality. Every path not taken in your life has been taken by another version of you in a parallel world. This concept might sound like it violates the conservation of energy. Proponents argue that you are not creating new energy. All the branches are part of the same single quantum system, the universal wave function. One of the most appealing aspects of the many worlds interpretation for physicists is its elegance and simplicity. It removes the arbitrary concept of wave function collapse from quantum theory. So what are these other worlds of the Level 3 multiverse really like? Well, for the most part, they're almost identical to our own. The vast majority of quantum splits are happening at a microscopic level and have no noticeable effect on our macroscopic world. However, over time, these tiny differences can accumulate. This is the essence of chaos theory, the butterfly effect. A tiny change in initial conditions can lead to vastly different outcomes down the line. It's crucial to understand that we can never, ever interact with these other worlds. Once a split occurs and the branches decohere, they're sealed off from one another forever. Despite this, the many worlds view is gaining traction among many physicists and cosmologists. They argue that a theory should be judged on its explanatory power and logical consistency, not just its ability to be directly tested. We've journeyed from distant copies of our universe in infinite space to separate bubble universes with different physical constants, and then to the constantly branching worlds of quantum mechanics. Now, we arrive at the final and most mind-altering level, the Level 4 Multiverse. This is the ultimate, all-encompassing multiverse, a concept so vast and abstract, it pushes the boundaries of science, philosophy, and imagination. The Level 4 Multiverse proposes that every single mathematical structure that is self-consistent and logical also corresponds to a physical reality. It's not just that maths is a useful tool for describing our universe, it's that maths is the universe. Every possible mathematical equation, every conceivable geometry, every abstract structure that a mathematician could ever dream up exists somewhere as a real, tangible universe. This is the pinnacle of the Copernican principle, the ultimate statement of mediocrity. It suggests that not only is our place in the universe not special, but the very laws of physics that govern our universe aren't special either. At the heart of the Level 4 multiverse is Max Tegmark's own bold proposal, which he calls the mathematical universe hypothesis. The hypothesis is elegantly simple. Our external physical reality is a mathematical structure. To grasp this concept, consider a computer simulation. A character inside a sophisticated video game would perceive their world as being real and physical. But from our perspective, we know that their entire reality is nothing more than information being processed. This hypothesis provides an answer to the ultimate why question. Why this universe? Why these specific laws of physics and constants? The answer from the MUH is that there's nothing special about our particular set of rules. Every consistent mathematical structure exists, and we find ourselves in this one simply because it's complex enough to support self-aware substructures, which is what we are. We are the universe's way of thinking about itself. The Level 4 multiverse dramatically expands our concept of what a universe can be. Other Level 4 universes might be based on cellular automata like Conway's Game of Life, or on mathematical structures that have nothing to do with space or time as we understand them. Imagine a universe that is a perfect four-dimensional crystal lattice with no concept of change or time, or a reality based on a different kind of number system, leading to realities that are fundamentally incomprehensible to us. It is likely that most of these mathematical structures would be simple, sterile, and uninteresting. They would lack the complexity needed for information processing, evolution, and the emergence of consciousness. This is why our universe, despite being just one mathematical structure among an infinite number, appears so special to us. It happens to possess the right mathematical properties that allow for conscious beings like us to evolve. The Level 4 multiverse, the set of all mathematical structures, is what Tegmark calls the ultimate ensemble theory. It represents the logical endpoint of the multiverse hierarchy, as it is the broadest and most inclusive class of universes imaginable. By definition, you cannot have a multiverse that is larger, because any such multiverse would itself be a mathematical structure, and therefore would already be included within Level 4. Of course, an idea this radical comes with huge criticism. The most obvious objection is that it is completely untestable and therefore unscientific. How could we ever hope to get evidence for a universe governed by different mathematical laws? Another significant challenge is the measure problem. If all mathematical structures exist, how do we explain why we find ourselves in this particular one? Without a way to calculate probabilities, the theory cannot predict anything. After our grand tour through the 4 levels of the multiverse, let's put them all side by side. Max Tegmark's classification gives us a wonderfully organized way to think about these different concepts, arranging them in a clear hierarchy. Think of it as a ladder of cosmic weirdness. The first rung, Level 1, is the most grounded, requiring no new physics. Moving up, each level becomes progressively more speculative and abstract. Another common thread running through all 4 levels is the Copernican principle, the idea that we do not occupy a special or privileged place in the cosmos. Each level extends this principle of mediocrity one step further. The type of variety found in each level increases dramatically, from simple particle arrangements in Level 1 to the ultimate variety of all possible mathematical structures in Level 4. The concept of the multiverse across all 4 levels ignites a fierce debate within the scientific community. The central point of contention is whether these ideas can truly be considered science. Science relies on the scientific method formulating hypotheses that make testable predictions, which can then be verified or falsified through experiment and observation. The problem with all 4 multiverse levels is that the other universes they propose are causally disconnected from our own. We cannot travel to them, see them, or interact with them in any way. Supporters argue that while we may not observe other universes directly, multiverse theories can still be scientific if they are necessary consequences of other testable theories. So, we've been on quite a journey, haven't we? We've traveled from the familiar shores of our own observable universe to the farthest, most speculative reaches of reality itself. We started with infinite space, creating cosmic copies, moved to bubble universes with different physics, then to quantum branching realities, and finally to the mathematical universe hypothesis. This reshapes our sense of scale, suggesting our cosmos is but a grain of sand on an infinite beach. Our entire history may be playing out again and again across an unimaginably vast expanse. We live in a rare Goldilocks bubble where conditions were just right for life. Most other universes would be sterile, failed experiments in the cosmic laboratory. So what are we to make of all this? Are we truly living in a multiverse? The honest answer is that we don't know for sure, and we may never know. These 4 levels represent a spectrum of possibilities, from the highly plausible to the wildly speculative. They are not proven facts, but are the logical endpoints of our most successful scientific theories. Ultimately, the quest to understand the multiverse is part of the great human adventure of exploration. For centuries, we have pushed the boundaries of our world. Now theoretical physics is pushing the boundaries of reality itself. These ideas encourage us to ask the biggest questions we can possibly ask. What is the nature of existence? Why is there something rather than nothing? And what is our role in this potentially infinite cosmic tapestry? The multiverse remains one of the most profound and tantalizing concepts ever conceived by the human mind. It leaves us with a sense of profound wonder and humility. As we gaze up at the night sky, we are left to ponder the staggering possibility that what we see is not the whole story, but just one chapter in an infinite library of cosmic tales. Thank you for joining me on this mind-bending exploration. Keep looking up and never stop asking questions. The cosmos may be infinitely larger and stranger than we ever dared to imagine.